Okay, so now today let's focus on the ellipse. An ellipse is a set of all points x, y in a plane whose sum of the distance from two fixed points, f1 and f2, we call them foci, is constant. That just sounds very wordy, doesn't it? Let me show you a quick clip. Okay, so those two pins are your foci. That string represents the distance to any point on that ellipse. And as you move it around, the string doesn't change size, okay? So that's just what it's referring to as an ellipse. So anytime, like if we talk about orbits, as things are moving around planets and moons and such, they move in elliptical format and there's this constant distance, okay? So that's what that's referring to. And we'll talk about foci a little bit more here in a minute. So every ellipse is graphed using two perpendicular axes of symmetry. The major axis is the longer axis, and the minor axis is the shorter axis. As we look at this picture below, the major axis in this ellipse is going left to right, and then the minor axis is the one going top to bottom. We also have 4 vertex points. There are 2 vertices, one at each endpoint of the major axis of symmetry. So we call this guy here a vertex, looking at our picture, and this guy here is a vertex. But then we have 2 co-vertices, one at each endpoint of the minor axis of symmetry. So a co-vertices here and a co-vertices there. We have one center that's located at the intersection of the 2 axes of symmetry, but it's also important to know that this center is also the midpoint for each axis of symmetry. Now, on the axis, the major axis of symmetry is our 2 foci. It's plural for focus. Each point is called a focus, and it's always on the major axis. And again, the sum, as we pointed out with that string and those 2 push pins, is always the same with that distance. Now we're going to be focusing on ellipses that are either elongated left to right or elongated up and down. But I personally don't like memorizing 2 different formulas and everything for how an ellipse works. So I'm going to kind of draw it sideways. We still have our major axis and our minor axis. We have the center here represented as HK, a vertex. Somewhere on that major, we'll have a focus. And then up here at the minor, we have the co-vertex. So in our formula, we're going to have variables that deal with distances between all of these points. The first variable is a variable A, and it's going to represent the distance from the center to the vertex. And again, that is on our major axis. Since your center is the center point, A on the right-hand side is going to be the same as the A on the left-hand side. The B is the distance from the center to our co-vertex. And again, that is on our minor axis. And our last variable is C, our last distance, and that is the distance from the center to a focus. Now, a couple of important things to note is our A value is always going to be larger than our B value because it's the distance on the major axis compared to the minor axis. And we also have a formula where A, B, and C are related, and it looks very similar to our Pythagorean theorem. But notice, unlike our Pythagorean theorem, the A is the longest side. So we have A squared minus B squared equals C squared. Or if it helps and you want to keep it in addition, you could say C squared plus B squared equals A squared, whichever one is easier for you to remember. So here's the formula for the ellipse, and they're actually going to look very similar. The horizontal ellipse is the one that is elongated left to right. So it's going to have x minus h squared over a squared plus y minus k squared over b squared equals 1. And it's always, oops, I said b squared, but I didn't write it. There you go. B squared equals 1. So notice here, a squared is the longer side and it's underneath the x. That tells us that it's elongated left to right. So larger number under the x means we're going left to right. With the vertical ellipse, that means it's elongated up and down. So the y values are larger. So we still have x minus h squared plus the y minus k quantity squared, everything equals to 1, but this time the a squared is underneath the y and the b squared is underneath the x. So again, larger number under the y, meaning we have an elongated ellipse that goes up and down like the y's, up and down. So let's try to write the standard form of an equation of an ellipse where we're given the vertices and the foci. Now, for me, I'm a visual learner, so it helps me to draw it. If I draw an ellipse and I know my vertices, didn't say co-vertices, so that tells me this is the major axis, the longer axis, has vertices at 0, 4, 1, 2, 3, 4, and -4. So there's my major axis there. And then my foci is at the square root of 15. So let's see, 4 is 16, 3 squared is 9. So square root of 15 is actually going to be close up in here somewhere. Square root of 15, negative square root of 15. So there's my foci. But I also have to find my, my b value. But before we find our b value, this gives us some information. This tells me that my center is at 0, 0. Because remember, my center is the midpoint of those vertices. And that distance between my center and my vertices is my a value. So I know my a value is 4. The distance from my center and my foci is my c value. So my c value is the square root of 15. So I need to find my b value. We know a squared minus b squared should equal our c squared value. Our a is 4, so 4 squared is 16, minus b squared equals c squared, or c is square root of 15. So that square gives us 15. So we get basically b squared equals 1, so b equals 1. There's one other value that I have. So that also tells me if I were to draw it, they didn't ask me to, but if I were to draw it, I know on my minor axis, I only go out to 1 and -1. So that's what my ellipse would look like. And it's supposed to be curvy and symmetrical, but we're just kind of sketching it. So I have my A and B, and really that's the only values that we need, A, B, and our center. When you're studying something new, I strongly recommend rewriting that formula every single time so you don't forget it. So x minus h squared over b squared, because it's not elongating left to right, but up and down. The plus, and the plus always reminds me, because everything looks almost like parabolas. Are they even parabolas? These are two parabolas that kind of go together, if you will, to make one big loop. So that's what reminds me that this guy has the plus, and then y minus k squared over a squared, and it always equals 1. Well, I know my h and k is my center, so x minus 0 is just x, so we get x squared. You know, y minus 0 is just y squared. Our b value we found to be 1. Our a value is 4, so square the 4 equals 1, always equals 1. So we just get x squared plus y squared over 16 equals 1. This is the equation of our ellipse. Example 2 is asking us to take the graph and find the equation for it. Well, it looks like the ellipse is elongated left to right, so this guy here would be our major axis. So we need to find the center of that. Looks like the distance, we're going from -4 to 6, so that's a total of 10 units. So if I go 5 units here in the middle, I end up at 1. So that looks like we have a center of 1, -3. You can also do it using the minor axis if that's easier. Find the distance there, which I think it's a total of 4, so it goes down 2. So we have a center of 1, 3. Then we have to find our A value, distance from center to the vertex. So from 1 to 6, that looks like 5 units. And then distance from the center to the co-vertex, that looks like, what, 2 units? Now, if we need to find the foci, we can use our formula to find it. But remember, in the equation, we don't use the c, so we don't have to have it. We have everything that we need here. Again, the ellipse is x minus h squared. Since it's elongated left to right, the larger number goes under the x, plus y minus k squared over b squared equals 1. So we plug in. Our h is 1. Our a is 5, so we squared it, we get 25. Our k is -3, so we get y plus 3 squared. Our b is 2, square it, we get 4. And again, it's always equal to 1. Now, in example 3, they're giving us an equation, and how can we tell it's an ellipse? Notice both the x and the y are squared. Both of their coefficients are positive. So at this point, it could be either an ellipse or a circle, but their coefficients are different. So we know it's an ellipse. They told us, but we can also look at the equation and figure that out. So we know that equation, again, x minus h squared. I know you guys get bored, but trust your Aunt Lainey on this. Write it down. It's always equal to 1. And again, make yourself a note. These may be switched. That's a question mark, okay? But that's just the generic form. We're asked to find the center, the vertices, the co-vertices, and the foci. So that means we need to find H, K, A, B, and C. And then we can use those characteristics to graph the ellipse. Do you have to find them first and then graph it? No. You could graph it first to help you if you're a visual learner to find it. But we're going to use our algebra first this time and then graph it second. So looking at our goal, though, looking at this equation to the right, we need it equal to 1. It is not equal to 1. It's equal to 144. So one thing we can do is divide everybody by 144 and then see kind of where we can go from there. So we're going to take the 16x squared plus the 9y squared equals 144. We're going to divide everybody by 144. So we get x squared over 9 plus y squared over 16 equals 1. Hey, look at there. We don't see an h and k, so that means we have a center at 0, 0. Now this also tells us that we have an a value of 4. Remember, a is the larger distance. It happens to be under the y. So we have an a value of 4, a b value of 3, and we can use those to find our c value. So we can take a squared minus b squared equaling c squared. So 16 minus 9 equals c squared. So 7 equals c squared. So c equals plus or minus square root of 7. But again, c is a distance. So we're going to say c is the square root of 7. Now again, you can graph it first. But remember, they're asking us to find vertices, co-vertices in the focus. So if you recall, the vertices, there's always 2, and they are a distances away from the center, but we need to know if it's distance left to right on the x or up and down on the y. Well, we look to see where our larger denominator is. It's underneath the y, so that means we go up and down. So for our vertices, our x is going to stay the same, but we're going to go up 4 units on the longer axis, the major axis, and then we're going to go down 4 units from the center, and those are our 2 vertices. For our co-vertices, those are on the minor axis, so that means we move left and right, so it's going to change our h or our x value. So if we move left 3 from our center, we would be at -3, 0. If we move to the right 3 from our center, we're at 3, 0. And also remember that our foci is on the major axis as well. And since our major is going up and down, it's going to change our y values. So we have 0 if we go up square root of 7, that's our c, or down square root of 7, also our c, so we get 0, negative square root of 7. So we found all of these without graphing, but again, you don't have to. If the graphing helps you, graph it first. It's always helped me. I am a visual learner. I'm still drawing it in my head, even if I'm not drawing it down on paper. So let's use these characteristics to draw our ellipse. We know our A is 4 and our center is 0, 0. So there's our center. We're going to go up 4. Go down 4. Our B is 3, so we're going to go to the right 3. We're going to go to the left 3. And technically, that's our ellipse. We don't have to draw the focus, but we can. A square root of 7, well, 3 squared is 9, so that's too high. 2 squared is 4, that's too low. So that square root of 7 is going to be in here somewhere. Square root of 7, negative square root of 7. This is 4, negative 4, 3, negative 3. So again, if you have to do the graph first and then, figure out the vertices because the visual helps, go for it. Example 4, we want to convert the equation of the ellipse into standard form. Now, if they hadn't told us an ellipse, how would we know? We have an x squared and we have a y squared. Everything else is smaller, okay? So we know we're dealing with a conic here. Both of them are positive, so we know it's an ellipse or a circle, but their coefficients are different, so we know it's an ellipse. If it was a circle, then it would be even all the way around. The A and the B would be the same. So we need to get our x's together, our y's together, and we need to complete the square. So let's rewrite this guy a little bit. Let's have 4x squared minus the 24x plus the y squared plus the 2y, and let's move that 21 over to the other side. And we want to complete the square for both the x's and the y's. So for the x's, there's a leading coefficient of 4, so we want to take that out. You get x squared minus, 6x plus some number to make the perfect square trinomial, plus the y's have no leading coefficient, so we just leave that y squared plus 2y plus something equals a negative 21. And again, we're going to add those two somethings to the right-hand side as well. We take that negative 6. We're going to take half of that negative 6, which is a negative 3. And then we're going to square that negative 3, and we get a 9. So we add a 9 here. But technically, it's 4 times 9, which is 36. So we have to add that equivalent 36 to the other side. Then we're going to do the same thing with this 2. We're going to take half of that 2, which is 1. Square that 1, and we get a 1. But there's nothing here, really. We're just multiplying by 1. 1 times 1 is 1. And so now we can simplify and change those to the binomial squares. So we get 4 times x minus 3 squared. Remember, it's always half this middle guy, plus y plus 1 squared equals, we add up the right-hand side, that gives us a 16. But again, we're dealing with an ellipse. So what does an ellipse look like? X minus h quantity squared plus y minus k quantity squared equals 1. And then either an a or a b, a squared, b squared, but those two may be switched. We don't know. So we have to get it equal to 1. So we're going to divide everybody by 16. So we get x minus 3 squared divided by 4 plus y plus 1 squared divided by 16 equals 1. We put it in standard form. It did not ask us to find the center, the vertices, but we could. All they asked for was the equation. So be sure that you're answering the question asked. Down here below, it's in your textbook, but I wanted to include it. This is for those of you that just like to memorize 2 different equations for 2 different stuff. And here's the H, you can subtract the K, you can do whatever. But all of this underneath here is everything we've already done. Just distance from A, know if you're going up and down, left or right. Your distance B, whether or not that's on the minor axis is going left or right or up or down. Find your focus. All of this is what we've just done. I just think it's in a more complicated format, and it looks like you're having to memorize a whole bunch of gobbledygook. If you like memorizing gobbledygook, I have presented it for you here. Otherwise, you put a big X through it and just focus on what we've already done. Okay, so I hope this has helped. I miss you guys. I can't believe we're almost done with this semester. It just doesn't seem right. So come and see me if you have any questions. Talk to you soon. Bye.